This video will demonstrate how to set up the ATV 25 and the ATV RT for automatic pair identification. It covers the setup and the operation of these units. The ATV 25 is used as the field unit in automatic pair identification. It is the unit that goes to the location where the pairs need to be identified. The ATV 25 is battery powered and can typically operate for 8 to 10 hours on a full charge. The ATV 25 includes a power supply that can be used to charge the internal battery as well as operate the unit. Both of these functions are possible at the same time. The ATV 25 includes the following cords: AC power cord, power supply, pair 0 cord with alligator clips, auxiliary cord with alligator clips, and a top pair cord. The ATV RT is the central office side of the tagger set. It is always placed where the cable and count is known. This may be the central office, but it could also be a cross-connect box or even a modular splice. The cables provided with the ATV RT include an AC power cord, an AC power supply, a pair access cord for tagging, an auxiliary cord, and a ground cord. In this demonstration, we will simulate the connection of the ATV RT to a cross-connect box. The ATV 25 will be at a splice and will be used to identify the pairs by communicating with the RT connected to the cable. The connector block is typical of one that might be found at a cross-connect box. A front tap shoe will be required to make the connections to this block. The front tap shoe is used to connect from the block a modular splice or from the central office MDF to the test set. The cable will have an appropriate head on one end for connection to the block and a cinch connector on the other end for connecting to the test set. A good ground is essential for all testing and pair identification operations. In this demonstration, we'll be using the bar at the bottom of the stand. This bar will be used to ensure that the ATV 25 and the ATV RT have a good ground between them. This is essential to ensure that the measurements taken at each end are matching. In actual operation, you should use the cable sheath, ground bar, or other facility that ensures that you have the best ground between the test sets and the cable. The ATV 25 and the ATV RT communicate with each other during tagging operations. Measurements taken from the ATV 25 are sent to the ATV RT, which searches and uses that information to find a matching pair and returns that information to the ATV 25. The communication is accomplished over a communications pair. The communications pair is a vacant pair. This pair is identified at the location where the ATV RT will set up. We will use the ATV 25 to identify a suitable pair. At this point in the demonstration, we're located at the cross-connect box. This is where the ATV RT will be placed. The ATV 25 test set is going to scan the 25 pairs and look for a vacant pair. This is a relatively fast operation. The communications pair should be a balanced vacant pair and long enough to reach from the cross-connect box to the point where the tagging will be performed. The pair should not have any battery and it should not have any grounds or shorts. The tap shoe is mounted securely to the connector block at the cross-connect. It's important to ensure that all the pins are straight, none of them are broken, and all making good connection. Any difficulties or problems that are found with the tap shoe should be corrected, as they will cause problems during the tagging operation. The other end of the tap shoe is connected to the ATV 25 to the cinch connector located on the bottom of the test set. This gives the ATV 25 access to all 25 pairs and allows automatic testing to begin. To start the automatic test at the ATV 25, press the test key. There are 6 options. The easiest way to test for a vacant pair is to use the vacant pair test. The up and down arrow buttons located on the 2 and 8 keys are used to move the cursor up and down to the desired test, and the F4 key, select, is used to start that test. The ATV 25 allows you to identify the CO, location, user, and if necessary a reference pair ID. In our case, we're going to set up the cable and the pair count because we'll save this result for later use. The arrow key is used again to move the cursor to the cable. The 5 key will allow us to change that value. We'll use the cable number 31 for this demonstration. The numbers 3-1 are pressed and F1 is pressed to save that value. We'll now enter the starting pair number for this count. We'll enter the start count by pressing the 5, then entering 201. In this demonstration, that will be our starting pair, and we'll hit save. Now you can see that the stop pair has already been set to 225, which will be the ending pair. At this point, I begin the test by pressing F1, start. The ATV 25 checks for available memory to ensure there is sufficient memory to store the test results, then begins the test. As the test proceeds, you will be able to see pairs that have potential problems by identifying the black background behind the pair number, in this case number 2. Each time the ATV 25 finishes a pair, it'll move to the next pair. The right hand side of the display shows you the current pair being tested. The left hand side shows the results of the previous pair test. At this point, half of the pairs have been tested. The current testing pair now is 214. This particular test is doing measurements of voltage, resistance, looking for grounds and shorts, capacitive, looking for balance and the length of the pair. All of this information for each one of the pairs is being measured and stored in the test set. The ATV 25 has finished testing the 25 pair and the cursor has been placed on the first pair. We can see that the first pair is a vacant pair and that pair may be suitable for our communications pair. We can also see other information about the 25 pair count, such as shorts, grounds, opens, and battery, which may be indications of POTS pairs or perhaps special circuits. This information is useful when we're tagging the pairs, as some of the pairs may be more difficult to identify than others. The first pair indicates that it's a vacant pair, so we're going to look at the test results by pressing the test viewer. In the test viewer, we can see that there's no DC voltage on this pair between the tip and ring, the tip and ground, or the ring and ground. We can also see that resistively there are no shorts or grounds. Looking at the capacitance, the pair is balanced because the tip to ground and ring to ground are the same, and the overall length of the pair is 1,790 feet. This pair would be acceptable as long as the point where the tagging is going to be conducted is not farther than 1,790 feet from this location. We'll use pair number 201 for our communications pair in this demonstration. Normally your communications pair is a pair that you're not going to be tagging as part of the normal tagging process. This pair will be identified and will not need to be further identified later in the tagging. So we can take this pair out of the scan count. When setting up the ATV RT, first you'll need to connect the power supply. The power supply for the ATV RT and the ATV 25 are both identical. They supply a 12 volt DC power to the test set. The ATV RT has a mechanical on-off switch. When you plug in the power, the green light may or may not come on. If the light does not come on, then press the switch to turn the ATV RT on. If the green light still does not come on, recheck the connections to the AC power, the power supply, and the plug connected to the ATV RT. The ATV RT should also be connected to the same ground that was used with the ATV 25. This ground has been verified by test results. Now we're going to connect the tap shoes. You can connect 1 to 4 tap shoes to the ATV RT. This is convenient because it saves time. If you're only going to be tagging 50 pair, then you only need to connect 50 pair, but they do need to be in sequence. So as you see on the front of the ATV RT, the first module is marked 1 to 25, the second module 26 to 50, third module is 51 to 75, and the last module is 76 to 100. Ensure that when you connect your tap shoe that the last 2 digits of your cable count match the connector. The reason for this is when the pair numbers are reported to the field location on the ATV 25, the number will be the position that the connector is on the test set. If you connect a tap shoe that's 1 through 25 to the 26 to 50 module, then when you tag pair 1, it'll be reported back as pair 26. When connecting the tap shoes, ensure that you inspect the cinch connector, ensure that you don't have bent or broken pins or any kind of trash or dirt in the connector. Reviewing our progress, we've connected a tap shoe to the 25 pair block at the cross connect box. We've connected that to the ATV 25 and scanned 25 pairs and identified a pair that we want to use for the communications. We've also connected the ATV RT ground and power supply and removed the tap shoe from the ATV 25 and connected it to the ATV RT. We now need to connect the communications pair from the RT to the pair previously identified. We want to ensure that the pair is okay and that everything is set up properly for the RT. We're going to use the blue aux cord for the communications pair, both on the ATV RT and a blue cord at the ATV 25. When we set up the RT, we're going to connect the blue cord initially to the ATV 25 in the pair 0 connector. This is to test the cord and to ensure that all the other connections are correct. The ATV 25 is still showing the test results from pair 201. That's the last thing that we did with the ATV 25. We're now going to press the clear key to go to the main menu. We're going to connect the blue cord, the aux cord from the ATV RT to the pair 0 jack. The pair 0 jack is located on the bottom of the ATV 25, immediately below the pair 0 label. The pair 0 cord is now connected, and we're going to connect the clips to the pair 201. The aux pair clips are now connected to pair 201. It doesn't matter if they're color reversed or not. We're now going to take a look at the pair and ensure the pair is okay using the aux cord for the ATV RT. F3 will start the ohm meter. We'll take a look at the ohm meter and ensure that we don't see any shorts or grounds on the pair. This is indicated by the greater than 10 meg between the tip and ring, greater than 10 meg between the tip and ground, and greater than 10 meg between ring and ground. If there were any voltages on the pair, they would be displayed in this meter mode. Next, I'll push the open meter button and we'll take a look at the capacitive values for the pair. We're looking at a balanced pair because we're looking at 1.78 on the tip to ground and 1.78 on the ring to ground. This indicates 1,780 feet of cable. Tip to ring, the pair is 1,790 to 1,800 feet long. So this is the same readings that we received when we scanned the pair earlier, but it also indicates that the pair cord that we're using to test is also good. If there were defects in the pair cord, such as an open clip, we would be able to see it. The next step is we'll disconnect the aux cord from the ATV 25 pair 0 connector. And now we'll connect the aux cord to the COM connector on the ATV RT. At this point, the ATV RT is set up for operation. It can send both remote tone and automatically identify pairs using the first connector, which is pairs 1 through 25. One of the steps at the splicing location will be to identify the communications pair. It'll be necessary to have tone on the pairs so that the splicer technician will be able to identify that pair to connect the ATV 25 at the far end. This is accomplished by the ATV RT automatically. The last step before leaving the ATV RT location is to ensure that there's tone leaving on the aux cord. This is done with a standard amplifier probe. The ATV RT will send 577 Hz tone until it receives a communications request from the ATV 25.